students, welcome back to Wisdom Academy YouTube channel. In the previous video, you have learnt about the image formation by a convex lens. Let me summarize that. So what we have seen, if the object was placed at infinite, the position of image was at focus, the size was point sized, nature was real and inverted. If it was beyond C, the image was formed between C and F, size was diminished and the nature was real and inverted. If the object was at C, image was at C, size was same size and nature was real and inverted. If the object was between C and F, position was beyond C, size is enlarged, nature is real and inverted. If the object was at focus, image was formed at infinite, size was highly enlarged and nature was real and inverted. And if the object is between focus and optical center, image was on the same side of the object, virtual and erect and enlarged. So you can relate all these cases with the case of concave mirror. So whatever were the ray diagrams for a concave mirror is very much analogous to ray diagrams by a convex lens. So this way you can remember that concave mirror and convex lens have similar kind of image formations, right? Now we will go to the image formation by a concave lens. Now let us see image formation by a concave lens. So how a concave lens is? Concave lens is thin in the center and thick at the edges. Now what happens when the ray is passing through concave lens? All the ray diagrams of the concave lens will be analogous to what you have learnt in convex mirror, right? So in convex mirror there was only two cases. One was keeping the object anywhere in front of the convex mirror, and second thing was object was at infinite. Same way here it will happen like that. Let us see how. So now this is the concave lens and this is optical center. This is F1, this is C1, this is F2 and this is C2. So what I am doing, I am keeping an object anywhere in front of the lens. Let me keep it between C and F and see what happens. So first ray, which is parallel to principal axis, will go and get diverged. I hope you remember that it is a diverging lens. It will diverge the ray in such a way that if you extend in the back side, it will pass through focus. Second ray, which is passing through optical center, will go without any deviation. This is the point of intersection. So what we saw if this is AB, the image is A dash, B dash here. What is the nature of the image? What is the position first? So nature, if I write here, first nature is, it is between O and F, between optical center and focus. Second thing is, it is virtual and erect. It is virtual and erect. And third thing is, it is diminished. So it is between optical center and focus, it is virtual and erect, it is diminished. Now if you want to try something else, let us keep the object between F and O and see what happens. So when the object is placed between F and O, so this is the optical center, this is F2, this is C2, this is F1 and this is C1. So I am keeping the object here. First ray being parallel to principal axis will get diverged like this in such a way that it is passing through the focus, and second ray will pass through optical center undeflected. See again, the image is found here. Can you feel? Same nature is there. Nature is exactly same as what you have written above. That is between O and F, virtual and erect and diminished. So wherever you keep the object in front of a concave lens, you will get the same nature of image. So the first case of the object was object in front of lens. So object in front of lens and nature will be always between optical center and focus, virtual and erect and diminished. Second case which is possible is when the object is at infinite. Object is at infinite. So what will happen? Let us see. This is the concave lens and this is the optical center. This is the F1, this is C1, this is F2 and this is C2. So ray is coming from infinite, it will get diverged. Second ray also coming from infinite gets diverged. So both, if you extend backwards, it will go and pass through focus. So it will meet at this point, focus. So what is the nature? Nature is where the image is formed. Image is formed at focus. What is the size of the image? Highly diminished or point sized. And what is the nature? It is virtual and erect. Since it is virtual, it will obviously be erect. So we can see that if the object is anywhere in front of the lens, then the image will be between O and F. The image will be virtual and erect it will be diminished, and if it is infinite, it will be at focus, virtual erect, and point sized. Now let us see what are the uses of these lenses. So what is the use of this convex lens, use of this concave lens? First of all, both the lenses are used in making the spectacles. So what you're wearing, no, for your eye defects, if you cannot see for far, if you cannot see near, so we use lenses, and those lenses are made by concave or convex lens. Another use is concave lenses, since it can have a higher range of view. See, big things will be seen in small. It is used in the door peephole. So in door you would have seen there is a small lens from which you can see from inside who is there outside. So there we use concave lens. Concave lens are also used in telescopes, whereas convex lens are used in magnifying glasses. It is used in microscope to magnify the image, and it is used as a basic magnifying glass. Have you seen that magnifying glass? There also we have a basic convex lens. These are the uses of spherical lenses. Now let us see lens formula. So in lens formula, first thing what you should know is sign convention. Sign convention is very similar to mirror's formula. So what was the first convention? The first convention was all the distances which are measured along the direction of incident ray are taken as positive. Same way here also, the same rule goes. The first rule, you can write in your notebook, all the distances measured along the direction of incident ray is taken as positive, and all the distances measured against the direction of incident ray is taken as negative. Second rule, all the heights measured above the principal axis is taken as positive, and all the heights measured below the principal axis is taken as negative. So these two are the important rules of sign convention. So with these sign convention rules only you can design the lens formula, you can use the lens formula, right? So let us see the first rule, and this was the lens. So this is a convex lens. So in convex lens you may have a doubt here. The doubt will be that there are two focus and there are two center of curvature. So whether I should take this focus or this focus. See which focus is being used. So here I have f1, here I have c1, here I have f2, and here I have c2. So suppose I keep the object between c and f, or anywhere in convex lens, then the ray goes like this and pass through this. So which focus we are using? This focus we are using. So in the convex lens, always the right hand side focus will be taken. If you are taking the object on the left hand side, this focus will be taken. So now this focus, if this is the direction of incident ray, this is the direction of incident ray. So what will be this? This is along the direction of incident ray. So focal length of convex lenses will always be positive. Please keep in your mind. Same way, if when you are taking the concave lens, remember that what focus we took? This was C1, this was F1, this was F2, and this was C2. Anywhere keeping the object, first ray was going parallel to principal axis, diverged, and this focus was used. This focus. So here the focal length will be taken as negative. So focal length of a concave lens is always negative. Focal length of a convex lens is always positive. Same way, object. See, object distance will always be negative. U will always be negative in any case. Here also see U. So U will always be negative only, because direction of incident ray will always be against the direction of U. And V depends. In this case, always the V is formed here only. So here V also will be negative. Here V also will be negative. So we can write very conveniently that in all the cases of concave lens, F, U and V, everything is always negative. But in the case of convex lens, when it comes to convex lens, then F is always positive, U is always negative, and V, see, always the image will be formed on this side only. Remember, always, except one case, when you had the object between F and O. So V will be either positive or negative. When it is positive, all cases except between O and F. So all the cases except the case when the object was between O and F, optical center and focus, it will always be positive, whereas V will be negative when the object is between O and F, optical center and focus. So this is one of the very important sign conventions. So you can remember this. when you will take U positive, V positive, V negative and F positive and negative. Now coming back to lens formula. So lens formula says that, what was Miller's formula? 1 by F is equal to 1 by V plus 1 by U. Lens formula will be 1 by F is equal to 1 by V minus 1 by U. So how this formula are being derived, you will learn in the higher class. In 12th you will learn how this formula is being derived. It leaves knowledge of similar triangles, which you will study in 10th standard. So next is magnification. Magnification is also a bit different from what you saw in the Miller's formula. Here there M was equal to minus V by U. Here M is equal to V by U. M was what? Height of image by height of object, and that is equal to V by U. This is the formula of magnification. And mind that same rule continues, that if you want to use these values when you are putting like F is equal to 25 centimeter, that time itself you should put plus or minus to avoid any confusion. When you are taking a numerical, in the beginning when you are taking the values itself, you should take what is positive and what is negative. There is one more concept called as power of lens. What is power? Power is reciprocal of focal length. So power is equal to 1 by F. Power is reciprocal of focal length. Power is always taken in diopters. The SI unit of power is diopter, represented by capital D. So SI unit of power is diopter, represented by capital D. First, what is power? Power is the ability of any lens to converge or diverge the light falling on it. That is its power. And mathematically it is reciprocal of focal length. One thing you should keep in mind, that always this F should be taken in meters. It should be taken in meters. In case someone wants to use in centimeter, then they should take the formula as 100 by F if you are taking F in centimeter. But to avoid the confusion, I will always say use this formula. P is equal to 1 by F with a take F in meters. So one more thing you can see from here, we know that F of concave lens sorry, is always negative, whereas F of convex lens is always positive. So whenever you see someone is wearing spectacles of power plus 2.5D, one thing is very sure, that he is wearing a convex lens. When they have to wear a convex lens and when they have to wear a concave lens, you will learn in the coming chapter, human eye. But now you understand that whenever you hear the word someone's power is, they will say I have power plus 2.5D. So understand that they are wearing a plus means convex lens. And you can also calculate its focal length. What lens they are wearing, what is its focal length, you can find, because you know P is equal to 1 by F. So P is equal to 1 by F. F is equal to 1 by P, so 1 by 2.5, that will be equal to 10 by 25. It is in meters, so multiply by 100 to get centimeters. So 10 by 25 into 100 centimeter, 25 fours are. So the focal length of the lens is 40 centimeter. This kind of numericals can be expected, where they will talk about the power. And if the power is a negative, he is wearing a concave lens. This thing you can keep in mind. Sometimes they will ask you in 1 mark question, a person is wearing a lens of plus 2.5 diopter, tell the nature of the lens. You can say nature of lens is convex lens. And if they ask you find its focal length, you can find accordingly what is the focal length by using the formula P is equal to 1 by F. One more thing sometimes is asked, combination of power. If there are more than one lens, 2 or 3 lenses, then power combination will be equal to P1 plus P2 plus P3 plus how many lenses are there. So 1 by F combination will be equal to 1 by F1 plus 1 by F2 plus 1 by Fn. This is the formula of combination of power and corresponding focal length. Now let us see one numerical. A 4 cm tall object is placed perpendicular to the principal axis of a convex lens of focal length 20 cm. If object distance is 30 cm from the lens, find the position, nature and size of the image. See, the first thing what you should see is what type of lens is this? Convex lens. So in a convex lens, what will be the focal length? Focal length will be negative. Sorry, convex lens will be positive. So F is equal to plus 20 centimeter. U will always be negative, whatever lens may be. So minus 30 centimeter. And they are also to find what is the value of V. What is the height? Okay, height of the object is also given. That is equal to 4 centimeter. height of the image they are asking you to find. So these two data we can get by using our formula, very easy. So we know that by lens formula 1 by f is equal to 1 by v minus 1 by u. So 1 by 20 is equal to 1 by v minus 1 by minus 30. So when you solve this, you will get 1 by v is equal to 1 by 20 minus 1 by 30. Take the LCM as 60, 3 minus 2. So 1 by v is equal to 1 by 60. So v is equal to 60 centimeter. So what we came to know? We came to know that in a convex lens, in this convex lens, when the object, suppose this is f1, this is f2, and this is c2, this is c1, the focal length was given as 20 centimeter. So this will be definitely 20 centimeter, and the object was placed at 30 centimeter. Somewhere here the object was placed, that is 30 centimeter from the optical center. We have got the image will be formed on the right side 60 centimeter. So we understood that image is formed somewhere here. Actually it will be inverted, we know it will be inverted. So it will be formed here at a distance of 60 centimeter from the optical center. So we came to know that object is formed 60 centimeter from the optical center. Next you want to find height of the image. Height of the object is given as 4 centimeter. We have to find as how much. One thing we know that when the object is placed between C and F, image will be beyond C, that we came to know. It will be enlarged, so it will be more. Let us see how it will be more. So M is equal to HI by HO is equal to V by U. So what is HI that you want to find? What is HO? 4 centimeter. It will be plus because it is straight. V is 60 and U is minus 30. So this will become 2. So what is HI? H came as minus 8 centimeter. Can you see? It became double the height, and minus shows it is upside down. So we got to know what is the V, what is the HI, and nature you can write it is real and inverted. Real and inverted. Let us see the next question. A concave lens of focal length 20 cm forms an image at a distance of 10 cm from the lens. What is the distance of object from lens? So in this question, it is a concave lens. So given quantity is focus. In a concave lens, focal length is negative. So f is equal to negative 20 cm. They have given image distance. So V will also be negative in concave. Everything is negative. So minus 10 cm. And they have asked you to find what is the value of U. If our solution is right, U will automatically become negative. Let us see that. So lens formula 1 by F is equal to 1 by V minus 1 by U. So 1 by minus 20 is equal to 1 by minus 10 minus 1 by U. So 1 by U will be equal to 1 by 20 minus 1 by 10. Take the LCM as 20. 1 minus 2 is 1 by U. So from here I get U is equal to minus 20 centimeter. So you came to know that in this concave lens, who had a focal, this is the focus, this is C, this is F2 and this is C2. When the focal length was 20 centimeter and the object was image was forming at 10 centimeter, so object was kept at the focus. Object was kept here, and so the image was forming somewhere here. So object was kept at 20 centimeter, image was forming at 10 centimeter, and focal length was 20 centimeter. This was the question. So in today's class we learned about the image formation by a concave lens. We learned what is the lens formula. We also learned about the power of the lens. We solved few numericals based upon that, and with this we come to an end of the first chapter, light. So in this chapter we have discussed about reflection, we discussed about refraction, we discussed about mirrors formula, discussed about lens formula. This chapter is one of the most important chapters of your 10th, which will have very high weightage in the board examination. So I request all of you to solve all the questions of NCERT and any other reference book what you have. And if you belong to some other board, you can take your textbook and solve questions from this chapter. Right? So with this, I am ending my today's session. If you have liked my video, please like it, comment in the comment section and subscribe my channel. Thank you very much.